In this video, let us continue to solve more problems based on surface areas and volumes of combinations of solids. And we've got a problem here which is based on a vessel which is in the form of an inverted cone. So this is that vessel. So the question is, the vessel is in the form of inverted cone. Its height is 8 centimeters and radius of its top is 5 centimeters, which is open. Now it is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped in the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Well, it's again a very simple and a straightforward problem. All we have to do is we have to find the volume of the cone and find what is 1/4 of the volume of the cone. Because when these lead shots, how many of them, each of which is a sphere. Okay, we need to find how many of them. When some number of lead shots are put into this cone, which is filled with water up to the brim, 25% or 1/4 water comes out. So that volume, the 1/4 volume of this cone, is equal to the total volume of lead shots, right? So once you equate that, you will find the total volume of the lead shots, which is in the form of sphere, and then we can divide the total volume of the lead shots by the volume of one sphere, and then you get the number of lead shots. And that's all this problem is. So let us start solving this problem now. So alright, first let us find the volume of water in the cone, which is nothing but the volume of the cone itself, right? Which is 1/3 pi r square h. So we have 1/3. Let's take pi as pi for now, and the radius is 5 centimeters. So if it's r square, it is 5 times 5 times the height, which is 8 centimeters. So solving this, we get 200 divided by 3 pi centimeter cube. So now what is the amount of volume that flows out? It is 1/4 of the water that flows out, right? So 1/4 of this value. So now let us find out volume of the water that flows out of the cone. Now that is nothing but 1/4, 1/4 times 200 pi by 3 centimeter cube. So 4 goes 50 times in 200. So we get 50 pi by 3 centimeter cube. So this is the volume of water that goes out. Now this is the same volume of the lead shots that come in, right? That's the most important thing. So now we need to find the volume of a spherical lead shot of radius. First, let us find the volume of one spherical lead shot, right? So let's do that. Volume of a spherical lead shot of radius 0.5 centimeter, which is the volume of a sphere is 4/3 pi r cube, right? So let us substitute that. It is 4/3 pi times the radius of that is 0.5 centimeter cube. So now 0.5 centimeter cube is nothing but 0.5 times 0.5 times 0.5. If you solve that, you can eventually get it in the form of the fraction 1/8. So 1/8 centimeter cube, 4 goes 2 times in 8. So we get pi by 6 centimeter cube. So the volume of one lead shot sphere is pi by 6 centimeter cube, right? So now let us say there were x number of lead shots, all right? So x number of lead shots, that is x times that volume, should give us the volume of water that went out, which is 50 pi by 3 centimeter cube, right? The most important point in this problem, the most important part is this, equating the volume of water that went out to the volume of the total number of leads. So how will you know the volume of the total number of leads? You don't know what is the total volume, right? So you need that number. Let's take it as x. So let's solve for x now. So pi and pi gets cancelled. So x is nothing but centimeter cube gets cancelled. So x is nothing but 50 times 6 by 3. So 3 times 2 is 6. So we've got x as 50 times 2, which is 100. So the number of lead shots that is dropped in the vessel is exactly 100. So that's all. So this problem is done. So let me quickly summarize this problem for you. There is this vessel in the form of a cone which is inverted, and the top is open. Then you pour water up to the brim. Then you put some number of lead shots, which displaces the water. The amount of water displaced is 1/4 of the volume. So we find that volume, how much water comes out. Now this volume should definitely be equal to the volume of lead shots that go in. So using this data, the radius 0.5 centimeter, and then that is a sphere, let us find the volume of one sphere. So that's volume of sphere into the number of leads, which we don't know, let's take it as x, should be equal to the volume of water that went out. So equating that, let's find the unknown, which is 100. Alright, so this ends this video. I'll see you in the forthcoming videos with more problems based on surface areas and volumes of combination of solids.